see them applied in ways we did not always anticipate.
Yeah. So let's move on to the most boring slide we have, and that's of course about us. I guess I'll start with myself this time.
Daniel Deogun, coder and quality defender. What does that mean?
Right. No. So basically, I tend to be a coding architect in my projects. I really love building secure and good software. I always strive to really make things with high quality, of course. And as you know, I'm one of the authors of the Secure by Design book. I currently work at Omega Point in Stockholm, and together with Dan Bergh Johnsson.
And you've also been speaking publicly on international conferences, but you have never been accepted to Java Zone.
No, I've been actually at Java Zone once.
Yeah. Sorry, I thought I was going to find out what you have, but that failed miserably. Well, Dan Bergh Johnsson, I was accepted to Java Zone from the very start. I was actually presenting the first 2 conferences at all there.
That's
well, also as Daniel, I'm a programmer at heart and education. Also do kind of architecture stuff, but I also dabble in like work habits, organization, like agile, and not the way agile has become sold as today, but more of the like trying to good stuff work together with the low, a lot of cooperation and low processes. I also tend to lean towards the philosophical parts, so that's why I became the secure domain philosophy. We both have a background in domain-driven design as one of our main influences for how we think about software. And in that regard, we also incorporated with a lot of people in Norway. Like a special shout out to Erlend Oftedal, of course, who was part of the domain-driven security movement for like 10 years ago. We're both employed at the Omega Point company, Swedish company, started by employees. We're working in the crossroad of secure digitalization and cybersecurity, where we think security matters the most, and we want to build good stuff.
Dan, I think they can Google us. I think now it's time to really move on to the fun stuff, right? So, let's move into the agenda, right? So there might be audience here that hasn't really learned a lot about secure by design. We figured we would throw in some fundamental ideas of secure by design, so you're all on the same page, so to say.
Basically, not covering all of it, Tennegard, but just to try to quickly line out the basic philosophy of it. But then we're not going to stay on that, but we're going to have a deep dive in 3 fields. So
right.
What are these?
So domain primitives, most of you know exactly what that is, which is great. But the idea is that we're going to give ourselves some self-critique and some insights regarding these 3 topics. And one being then, of course, domain primitives. The other one is validation and how it's done. And then we have the externalized secrets.
So we picked 3 parts where we did something, we said something, and then people have listened to us or not listened to us or listened to selected parts of what we've said. And then we have seen practices coming back, and we've seen things and say that, this vaguely resembles what we said or what we intended to said, but it didn't turn out exactly as we anticipated. With sometimes things subtly misses the point, or that we have failed to convey a point. So that is what this presentation about. We want to clarify a few of the points that we probably have been vague about, given a few years of experience.
Right. But in case some of you need to run away or leave for something before we reach the end, here's the summary of this talk. So basically, secure by design is a mindset and strategy for creating secure software, and we sort of piggyback our drive to use good design. I mean, that's one of the keys here.
And one of the misconceptions within domain secure by design is that when using domain primitives, they sometimes end up being anemic domain object instead of the kind of rich objects that they were intended to, which potentially could open up for new security vulnerabilities.
We're also going to talk about the input validation and how the concept of state validation somehow is missed and or skipped, and that actually leads to a lot of problems, which is very unfortunate.
And last, we're going to have a look at the externalized configuration and patterns and 3 R's of enterprise security, which were intended to go towards a full-fledged secret revocation. But there are a lot of subtle dead ends, and most important, we have found one pattern which we call config injection at startup, which seems to look like it heeds in the right direction, but actually that will take us a little bit straight path from where we really want to go.
Right. So let's start by looking at software bugs. Dan.
We start with software, and of course we start with bugs. We all know software always starts with bugs. If you got a program, you can always reduce it with one line, and you will always have one bug. So at least at the end of the day, you will have one line of code containing one bug. So there are bugs, a lot of bugs that are possible. So, and some of them have security implications. And this is one of our key messages, that security bugs are essentially no different from normal bugs. It's just misbehaving code that does a little bit too little or a little bit too much.
But Dan, what is a security bug compared to a normal bug?
Okay, so a bug is misbehaving software that have some kind of security side effect. For example, that you have flaws in the confidentiality of data, so you reveal data that it shouldn't. Mm-hmm. Flaws that give some kind of integrity problem with the data, that it can be changed in ways it shouldn't be changed, or availability, that you should be able to get at this, but you can't. So this is the CIA triad that I guess is familiar. Of course, also we had the T for traceability.
Right.
So how do we avoid software bugs?
Well, the most common way of doing it is you apply some sort of design to it, right? I mean, you apply either a pattern or something that you change your software or your code in a way that allows this bug to disappear.
Okay. Yeah. So, for example, a software design could be to use immutable value objects.
Correct. Yeah.
And that would not solve all bugs in the universe.
Mm-hmm. No.
But rather some sphere of it.
Right.
And who said that this design would lower the risk for a certain class of bugs, some normal bugs, but also some security bugs. Yeah. So that's a nice design.
Right.
Have got more designs.
Of course. I mean, yeah.
That's not just one design in the universe.
Mm-hmm. So there's a lot of design patterns out there, a lot of designs that you can apply to avoid certain bugs.
Okay. So if you use all the design patterns that are in this picture, you will avoid all bugs. You will get a guarantee that you never have bugs.
No. I mean, a lot of them probably, but there are bugs still out there.
Okay, right? So it's a heuristic, a risk reduction technique.
But Dan, what's this about secure by design, by the way?
Oh, okay. So of course we love design. And we have found that there are a lot of interesting designs that have got the security benefit, that they lower the risk of security bugs. So, for example, the 4 circles marked in green they all contain some kind of security bug that they reduce. However, there are, of course, a lot of other interesting designs. For example, the 2 circles with 4 or 5 respective squares in them. So these are designs that we love and use, but we can't say they've got a direct security benefit.
Okay.
So secured by, so what have we done under the umbrella of secured by design?
Okay. So you're saying now that there are certain design patterns that can be applied to avoid security problems, and if they do, we consider them as a secure by design pattern.
And just to be clear, this is a general philosophy. And all of you sit in your experience with a lot of design patterns that you do because you want to build good software. And some of them, you realize yourself that, oh, this is also good because it diminishes the risk for a certain kind of security bugs. Bingo, you are applying secure by design. So what about the book?
Right.
And the patterns we collected in them?
Right, yeah. So when you write a book, you have to, of course, be a bit more precise. Maybe you can't just draw circles and say, hey, this is secure by design.
Okay.
So we had to come up with some sort of I don't know, elevator pitch for this. I guess we call it it's a mindset and strategy for creating secure software by focusing on good design. Right?
And this, I'm completely sure that of the people in this room right now, the vast majority of you are doing this all the time and have been doing it for years.
Mm-hmm.
So just let's be clear that what we captured in the book was our kind of like library of first describing the methodology, of course, but also trying to collect our collective experience of these are examples of designs that we have found that we have realized have security benefits. And that list is to no extent comprehensive. We have had excellent discussions with a lot of you. For example, we had several of our reviewers were from Norway who pointed out a lot of other interesting directions. So the material in the book is our experience, but we think that the general philosophy of the design is a good tool to get security by focusing on the design is worth more.
Yep. So in this talk, like Dan said in the beginning here, that we have, of course, the CIAT is a, as I said, it's part of almost the DNA of Secure by Design, and it's a red thread throughout the entire book. And in this talk, we are going to focus on the 3 areas of domain primitives and secure state handling, and a part of the 3 R's. So I really think, Dan, that we should jump into that because now everybody's on the same page, and we can move on.
So now we're going to dive in 3 different areas where we have realized that, oh, we could have been clear. First of them is domain primitives. So we're going to look at what we said. Like we've been presenting this in the book, and we've been presenting it at conference talks and in communities, and in our assignments as consultants. So we're going to look at what we really said.
And then, of course, we're going to talk about the misconception and really what we intended, right? And then give ourselves some insights and self-critique, I guess.
Share a little bit of our insights.
Yeah. So let's start.
Yeah.
Domain primitives.
Domain primitives. What we said, that we described domain primitive as a domain pattern with a kind of wordy where a value object, like the ones we understand from domain-driven design, that is so precise in its definition that by its mere existing, well, that the object actually exists, manifests its validity. So it's valid just because it says exist. Such an object we call a domain primitive.
So that really means that we took the properties. We say we're going to take the properties from domain-driven design, right? From a value object. It's going to be immutable.
Yeah.
And we also say that it can only exist if it is valid in that context, right?
In that context. So it's native to the domain. For example, we're talking about room numbers in the hospitality domain.
Right.
And or a phone number in telecom. And said that an object must be constructed in such a way that we can't sit with an invalid phone number. If it is a phone number object, it must inherently be valid. Otherwise, we wouldn't allow for its construction. So this is the design pattern of creating a domain primitive.
So this is super clear. How can this be misunderstood, Dan?
That's
Yeah. All right. So yeah.
Let's have a look at an example. Just to you know what we're talking about. For example, I mentioned phone numbers, but
yeah, let's consider a tax ID. You probably have these in Norway as well. Yes. In Sweden, they look at like this. They are 10 digits in total. They contain the birth date, year, month, day. There's a birth number, that's 3 digits, and then there's a control digits.
According to the Loon algorithm.
Right. And then there's a separator between birth date and birth number, depending on if you're less than 100 years old or not.
Yes, because you note that we in Sweden were so intelligent that we saved 2 digits by not including the century you were born.
Yeah, terrific.
Side note is that there is an upgrade of the Swedish tax ID which does contain all the 12 digits. It hasn't got mandatory status yet, so it's still allowed to have these 10-digit Swedish tax ID.
So we see 2 examples here, one born in 1966 and one born in 2002. Yeah. So yeah, let's move on.
An interesting detail there is also that if you look at the last of the 3 digits in the birth number, we separate gender at birth by having odd or even numbers.
That's right.
Interesting detail.
Yeah, that's a side note. All right, let's move on. So these complex rules that we have here, what that tend to yield is that developers find it quite tricky to represent this. So they choose a data type that's flexible enough to represent this.
Yeah. It's a string.
Yeah.
Everything is a string. Like Java is a stringly typed language. Everything is a string. Yeah.
Right.
Which of course works. We make it work. We are intelligent programmers, but we inside this register this person for whatever purpose is, registering for voting, for example, we must write code and often write code that assume that the input is a tax ID.
Right. So the logic inside this method here would actually assume that the input tax ID would be indeed a tax ID.
Yeah, and not something else.
Yeah. But what happens, of course, is that, well, the developer is creating the logic according to that, but the attacker, of course, looks at the data type and say,
note that I'm allowed to send in anything.
Right.
I can craft an attract vector string here and send it in.
So the solution to this is, of course, to use a domain primitive. In this case, in this type of domain, a tax ID would be valid, and that tax ID would, limit the attack vector to only be acceptable IDs in that particular context.
And in this way, the inside logic now knows, it doesn't need to assume, it knows that the input is actually a tax ID.
Yeah. So all good, right? Well, here comes the misconception then.
So what we did was that, did you see that we really stressed the security benefits, saying that the tax ID is validated. So the validation logic is inside the tax ID domain primitive. And then we've seen that people can do this, but then when they try to use the tax ID, we get this kind of code.
Right. So in what we're seeing here on the screen is that there's a method eligible to vote. This sends in a list of tax IDs.
Hooray, they're using the domain primitive.
Yeah. And the election day, I guess, they do some basic checks on the input. And then they create a loop. And this is some complex logic where they extract the offset year, month, day, date of birth, and so on. And well, there's some logic, I guess, that computes, date of birth. And then if they are 18 or older, they collect those, I guess.
For the voting list.
Yeah.
Sure.
Okay.
So what we say here is that you can look the domain primitive becomes just a data container, a struct more or less, a validated struct, which is the point. But it is the interpretation of the data is kind of like done on the outside.
Yeah. So.
And this was not what we intended.
No, not at all.
I mean, do you remember we said that domain primitives were value objects?
Right.
So they build upon the original idea of object orientation.
Yeah.
Which is?
Well, messaging, I would say, and encapsulation, right?
So messaging meaning that the object itself will handle its inner workings. And we all know about data encapsulation. But the point of data encapsulation is not to hide the data. It's to encapsulate the behavior, the interpretation of the data. So what good is it if you encapsulate and hide the data, but then still have all the interpretations of the data on the outside? That kind of makes no point for implementation. So what we want to do is that we want to have the domain primitive being a real object, something that contains its state, it contains its data, encapsulated, yes, but together with the data, it should also contain the interpretation of the data. It should be able to answer sensible questions about the data.
I would almost phrase this as a small, intelligent machine.
Yeah, it can do stuff for you.
Yeah. So to clarify, I mean, we wanted the tax ID in this example to be an intelligent object with, an API or an interface on top of it. So in this case, we would have an immutable object satisfying the rules and implementing, I guess, this API here.
So these are the things you can learn from text ID. You can look at it and actually have the gender answered by the text ID.
Or I guess the eligible to vote. Well, it's a little weird to have that inside of a tax ID, I guess. But let's use it as an example of encapsulation, right?
Of course, in a real world domain, you shouldn't embed the functionality or the logic about voting eligibility inside this object. Yeah. But just understand, we need to embed some rule somewhere. So make it a pedagogical example.
But the key point here is that the domain primitive is responsible and knows everything about its data
and how to interpret it.
Exactly. The consumer or user or client of this data doesn't need to care about it. So
if you back up one of the key litmus tests here is that when you read the ways that the surrounding access the data, in this case the text ID, it doesn't do it by substringing out different fields, because that's a technical level interaction.
Yeah.
It does it on method that carries domain understanding. Gender, eligibility, age, birth region, it's about the domain. It doesn't talk about the data. The understanding about the interpretation of the data is encapsulated. We are looking at a domain level representation of that knowledge.
Good. So if we do apply this type of design, the code that interacts with the domain primitive becomes quite simple. As you see here, we suddenly are back in the method that contains all that complexity. We create a stream and traverse the tax IDs, and we apply a filter.
Daniel, what has you been doing? It's like you've been cheating. I mean, all that code is just disappeared.
Right. Well, it sort of disappeared inside of the tax ID, of course.
Okay. And the point here is, of course, that if we put the interpretation of the data inside the object, it carries a better chance of getting reused, which means that it's exercised more often, which means that it's got a lower chance of carrying bugs.
And as it turns out, that the code we saw before was actually incorrect, right? Because this one actually checks you can also be 18 on the election day, right? I mean,
you all noted that, I guess, that the code we had earlier actually missed the edge case that if you try to vote on your 18th birthday, you will not be eligible to vote. But you saw that. Here we corrected it. So, and also a side note on that is that if you do condense it in this way, there's a higher chance that you actually write unit tests for it. Because now you can unit test all these methods. But when that functionality was spread out in a lot of like helper methods, the chance of them getting unit tested in a precise way is virtually zero.
Yeah. So why didn't people write code this way?
How about why did this? We were so clear.
Yeah.
We even said object, and people didn't understand. Yeah. So, okay, we did oversell it perhaps a little bit. We said that security is an interesting and important trait of domain primitives, and we talked about security as a way of like selling the idea.
I would almost say that we stressed it so hard that we say, you know, in order to reduce the risk of injection attacks, you can use domain primitives. Yeah. And the security aspect of a domain primitive became what people were focusing on. Yeah.
So we didn't say it clearly enough that it is just one aspect of them. Not even the most important. It's just the side effect we want to stress. And as you all know, secure by design, the entire idea is that you use the designs to get security.
So as you all saw that if you design your code using domain primitive as we intended, suddenly the code around that in the interaction with the domain primitive became a lot simpler. And that was our original intention, that we created a design pattern that allowed us to, you know, create better, higher quality code, and then have security as a benefit, so to say. But unfortunately, people were focusing on the security part, made the domain object very anemic, only did, I guess, validation part of it, saying, okay, I validate the value inside of this, and then move the logic outside into either helper methods or whatever util methods they were or tools they were using. So
the beauty of it is really that it is a design with the security benefits, even though it was not originally designed with security in mind. It just happens to have beautiful security benefits. And the way of our fielding it kind of like overruled that original purpose. So, I mean, we should all remember, it is secure by design. We're using design as the focus to also get some security. It's not designed by secure.
But I do have to give us some credit, though, Dan. The thing was that in order for get traction out there, for getting people's attention, we had to focus on security. And we all love security, but not all developers do. So this was sort of
outside this room,
yeah.
Of course, we are in a robust chapter.
So the thing is that sort of gave us a chance to talk about these type of concepts, right? In order to push for that. So, but yeah, now though we are still trying to make people design it the way we intended. So yeah. All right, moving on.
We should move on. Let's have a deep dive into the second subject, which is about validation and state. Again, we're going to have a look at what we said, a misconception that surfaced it. Take a step back and look at say what we intended to say, and then apply some insights and self-critique.
Right. Okay. So, order of validation, Dan. What did we say?
This is a list of validation which we actually, to give credit where credit is due, has gotten from Dr. John Wilander, by the way, who was the founder of the Swedish OWASP chapter. And in one of his works, unfortunately not published, he listed a list of 5 steps of how to do validation, saying that start with, look what is the origin of the data? Is the data from a legitimate sender?
Mm-hmm. That makes sense. I mean, can this method be called from whatever object or an API. Can a client call this API and so on, right? Yeah.
For example, in an API, does the call come from a trusted part of the internet?
Mm-hmm.
Second, look at the size of the message.
Right. So you're saying that if you accept an address object, it can't be 2 megabytes.
If you get an address, which is an address method which is 2 megabytes, someone is probably trying to just throw it away. Don't open that package.
Okay, so size is actually important. Okay, good.
So next step, look at the lexical content of it. Okay, it's reasonable size. We open it up and look at what's in it.
So lexical content, it means a lexical scan. It doesn't really make any interpretation. It just checks that the characters in there are the expected ones, right?
So we don't start parsing yet. We just scan through it and say, looks fine.
All right.
No bomb.
Okay.
If we've done that, if it comes from trusted areas, trusted sender, it's a correct size lexical content, then we open up and look at the syntax. And now we actually parse it.
Okay. So, all right. So that means that's when we apply the regular expression engine, right?
The regular expression, and we do the JSON parsing, etc.
So checking the actual content and is this correct? Yeah. Okay. Semantics then.
Semantics. Does this data make sense at this point of time, given the state? So this is a list. I think it's a nice list. Yeah. It scans through from easy things to hard things. Origin is just checking the IP address or API key down, and then it's becoming more and more expensive to do it. Applying a parser for checking syntax expensive. Semantics, you'd probably have to open the database. So it makes sense to do it in this. I think John Land did a good work. Okay. So that's why we included it.
So the misconception, I mean, that was pretty clear, I thought. But unfortunately, not the community didn't.
No. And the problem here is that the word validation often is interpreted as validation of the input argument.
Input argument validation?
Yeah, not validation.
But that's just a subset.
It's just a subset. And it's that's not strange, because input validations often describe thereof, and that it's important to validate your input arguments, etc. So the misconception was that, well, the first part, origin, that's part of infrastructure. That will be some kind of API manager that checks the IP address and the API key or the TLS mutual certificate or something like that. So code doesn't have to do that.
But what about size then? Did you check size?
Size, probably, yeah. So
length is
length less than.
Okay. What about
lexical content? Well, sometimes skipped, and then you take the syntax by a kind of regex.
Okay, so they don't do lexical. They did only size and syntax check.
Yeah, or lexical content, a little bit like in between the lines. As part of regex.
Okay, and semantics then, did they do that?
And then semantics just disappeared.
Okay.
So this is kind of
of course it makes sense, right?
Yeah, of course makes sense. Why should someone send me data that doesn't make sense to apply at the moment?
Yeah. Okay.
I wonder, can anyone come up with an idea why someone would like to send you data that does not make sense? They might be trying to trick you.
Like every attack out there. Okay. So let's look at a small example, very quick one. So this is really what they did, right?
Yes, this is kind of code we find. Well, instead of having the stupid string ISBN with checking length, shard, register, and checksum, we have a domain primitive. And the domain primitive neatly embedded, for example, size, lexical, and syntactic check of the ISBN.
Okay, nice. Okay.
So there's no need to do that checking within it, because it's validated in constructor. And then we got the logic to add this book to the order. Well, assuming what?
Okay. So, I mean, I think this makes sense, right? Doesn't it? Or
but if we think about it one more time, what do we assume when we code the add book? We assume that add book is allowed.
Okay. So you mean that someone can call this method when it's not okay?
No, but they shouldn't. They don't.
Right.
Of course, we write the code that calls add book, and we would never call add book unless it's allowed to. We will call add book when it's in the store, when it's under payment or whatever, but will not add book after it's paid or after it's shipped.
Right.
We simply wouldn't do that.
I mean, who would?
Who would?
Yeah.
Who would try to add a book to the order after it's been paid?
Oh, okay. So,
That
right.
could never happen.
No. Okay. So let's move back to what we really intended when we talked about validation. I mean, first of all, we did not mean input argument validation. We mean validation, the full stack, right? We do acknowledge that, the first part of this list could be part of the infrastructure, like
It is
API
often,
manager.
in my experience at least. It's IP access, it's Joe token, it's API keys, it's
right. So somehow the origin is then validated. So we can trust our infrastructure maybe if you want to do that. But then you have the step 2 to 5. That's really part of the validation, right?
We want to stress, and here we want to clarify what we really meant, that semantic validation is an important part of validation. So let's not forget about it.
Mm-hmm. So the interesting part here is that since we are focusing on actually doing lexical content scan, the syntax, and the semantics part of this, we somehow target the fact that the code cannot be called at an inappropriate time.
Yeah. So how does that manifest itself in code?
Well, if you look at the book order example once more, you can see that inside of the book order object, then I guess, if there's a REST API, or this is street REST, I guess.
We can take left-hand side. Like if we're talking about inside code, we would do some kind of validity state check.
Yeah.
Real stage checking that the add book is called at an occasion when the valid state, it is in the state open.
So,
but if we take that into an API,
right, it would look something like this, I guess, that you would say, well, you add your book, right? And then you want to ship your order,
yep.
And then you try to add another book. Well, then of course this is not allowed anymore. So you get a 422 in this case.
405, 422, pick something. And this is something that if we look at the APIs that we have been developing and the APIs that we have been auditing, or the APIs that we've been integrating towards, we very seldom see an API which upholds state restrictions. Most of the time you can post stuff, you can put stuff, you can get stuff, but you never stay the risk of getting a 405 or a 422 back, saying that, I'm sorry, the entity you are interacting with is now in a state where will not any longer accept this message of yours.
And that's very interesting. What you suddenly say there is that there is obviously some logic in this code that verifies that the semantics of this call makes sense.
Not only is it a valid input, but also does the input make sense at this point of time?
Yeah. So in this case here, well, when you did this post up here, it was perfectly fine because the order was open. Then you shipped the order, and suddenly you try to add another book. And obviously you cannot do that because now it's already shipped.
So how come, I think this is really interesting.
Yeah.
How come this kind of state is not upheld?
Right. So yeah, this is...
So some insight and self-critique I think is valid here.
Yeah.
How come that we have failed to convey that this is also validation?
I think this also comes back to, how should I say, the part where we focus a lot on the injection attacks. That, injection attacks is number one on the OWASP top 10 list, right?
It was for a long time.
Yeah.
In its various versions, SQL injection, cross-site scription is also injection attack.
So it's the fact that injection attacks are so, scary, people tend to focus on input.
Mm.
And when you focus on input, you say, all right, I need to do validation of this input.
Mm.
And therefore, they sort of made this, synonym, saying input validation and validation are the same.
Which also is, if you look at the OWASP guides, they say the same thing. They talk about validation in the sense of input validation, in the context of input validation. So no fault of theirs, but it's contextualized to talk about protecting yourself from cross-site scripting or SQL injection attacks. And also, our fault is that we have thought this was such an important thing. We put it at front of the book, one of the first chapters. We have been given presentation on it at conferences on this subject repeatedly, several times in different versions of it.
But I would say also that I have to give John then a bit of critique, right? The list seems simple, but there are two parts of that list that are quite complex. One being, the lexical part, right? Even understanding what does lexical content mean, and the last step, semantics. I mean, of course, it makes sense to call this method now, right? Because you're doing it. And I would say that in most applications, we have this, I would almost call it a dark matter, right? Mm-hmm. This flow of logic that you don't protect against it because it doesn't make sense to call your service or methods or whatever it is. You say, well, nobody should, because you shouldn't.
So the legitimate calls to add book are in the flows,
right?
Are the process where it makes sense. In the other flows, there simply are no calls to add book. That's the dark matter.
Yeah, they consider negative tests, right? Yeah. And negative testing isn't really something that people tend to focus on.
There is another element to this also, adhering to the second bullet point here, is that if you look at how state is modeled within application, we often find that when we start looking at the application, the state of, for example, an order is contained in a database with some kind of line items and order and order lines or something like that. But then when you look at the code, it just simply uses this as a struct and manipulates it. Very, very seldom, or less seldom, that piece of data has got an active representation as an object which is encapsulating data and behavior. It's more like this is a struct which we manipulate from the side. So the state is not explicitly modeled, it's just implicitly modeled. There's an understanding of it there. And if you haven't got an explicit modeling of it, it makes it less intuitive to validate. I mean, we've been working on applications where we end up making jokes about the flags of the system. Like, yeah, this is an order with that, and then there's a flag if it's Norwegian or not, there's a flag where there's a company or not, there's a flag whether, and depending on these flags that you run around interpreting, you will apply different business rules. What you really have there is that you really have a complicated state machine. But that really complicated state machine is not explicitly modeled. It's just implicitly modeled by having all these flags that can be on and off, and that will guide and turn on and off different kind of business behavior. But it hasn't given it an explicit representation, and that makes it less probable that someone will do state validation. And often these flag grows over time, so that it becomes even more and more widely. And well, Sooner or less, people just give up and just interpret it.
Yeah. The good part about validation, though, Dan, is that people tend to at least apply it on the input, which is good.
Which is good. Definitely good.
So yeah, but you just need to have them do also state validation now. So yeah, that's
we
the
can
next
also
step.
note that in the book we wrote 2 pretty dense chapters on this, and I know that those chapters are I think they are among the largest in the book.
Yeah.
But we have never presented a single presentation, any of us, about this dedicated to state security.
Yeah. Well, maybe we should do that in the future.
Yeah.
Let's move on.
Not today.
Yes.
So let's look at the third part we were going to dive into, which is externalized secrets.
Right.
So how to manage secrets in your infrastructure and code.
Yeah. Guess what? We're going to use the exact same structure as the previous 2 topics.
Look at what we said. Look at the misconception. Pull back and say, what did we really intend? And then apply some insights. So, externalized secrets. What did we say?
Well, one thing we really stressed was that secrets, they should not be bundled with the application because they vary between environments.
We've all made the mistake. Oh, I've got to build pipeline. Oh, I've got a young application, so I've got all my config in a config file, which is in the Git repo. And oops, also the password to the database. But that's fair enough. We all bake it together in the pipeline and deploy it to the environment. Oh, we shouldn't do that. So we pull out the secrets and say, we'll apply the secret at a later point of stage. Instead, we will not have them in the application as such. Instead, we'll have some kind of properties of the application. So when we make our immutable build, it's got configuration points.
So we said that, if you externalize your secrets, you can provide them to the application. And then a nice benefit of this is that it allows us to rotate secrets.
Yeah, that is what we want to do at the end.
Mm-hmm.
For example, how often do we change the password in the production database? Once every
hour?
Decade?
Well,
sometimes, we've been with assignments, we've been working with clients where they rotate that password every hour. We have been working with clients where they rotate that secret every decade.
And we've been at clients where they, never rotate their secrets. Yeah, they did it once, and that was when they created it. Yeah.
When they were a startup.
Okay, so let's look at the misconception, because this sounds very simple in my mind, at least, that, okay, I externalize my secrets, and then I provide it to the application, and then I can rotate.
When do I provide the secrets to the application?
What do you mean, when?
When? At what point? I'm sitting here with a production database. I've got a build coming over here, but the build doesn't have any password database. I need to plug into that hole. I need to fill that property at some point of time. So when do I do it? Of course, I do it when I deploy it to the environment. When I deploy it, when I start the instance, I will plug into all those things. I will plug in the IP address to the message queue. I will get the production database password into there. I will get all the stuff that's needed so that when it's configured, it can actually run on itself. After startup, it can run on itself.
So, that makes sense if you look at this picture here. This is our database here. We have the secret X in these services or whatever it is.
Nice. I just put them in there with the X. I just put them in there when I started it.
So then
you know what? I'm so proud of it because I built it with the simple tools I found at my backyard in my infrastructure. I didn't have any fancy stuff. I did some bash scripts and I did some environment configs and I just nailed it to and now it's running beautifully.
So Okay, so what you did then, and this is the misconception, that people don't have the, I guess, the necessary infrastructure to properly externalize their secrets with the capability of rotation.
Well,
Right.
could you say that rotation part once again?
Okay, yeah. So what they do is that they say, okay, so we have bundled the secrets with our services or apps, right? And because that was a bad thing to do, we decided, well, we can take a first step and we can externalize this secret. Okay, so it belongs to the environment. So what they do is that they, like you said, they keep that secret in some sort of secure place somewhere that only a few people have access to, or maybe has to build pipeline.
The pipeline will use it.
And what they do is that they create an immutable deployment, I would say, right? I mean, they inject this secret inside of the application, but the problem then is that when they change the secret to the database, they are going to have applications with the old secret in there, right?
So when you change the database in the production database, the production database password, then a few of my instances will sit with the old password,
and they can't recover, right?
Can't recover. They will just terminate. But that's okay. I will just spin up new instances with the new password and let the old instances die.
Yeah, sure. I mean, that's actually, if that's acceptable, yeah, you could do that.
But you all hear that it's a little bit of an awkward patch. But just to be clear and honest, I have done this. It's not a bad solution. It takes you out of a bad place, and it can be built by stuff you got lying around on your on-prem DevOps backyard, because you haven't got any fancy vault solutions and stuff like that, and identity managers and stuff like that. You got a few bash scripts at your hands, bash script that you build yourself, and then you can craft this, and it works, and it's better.
But the problem then is you are moving into a dead end, and
but we are getting into dead end where we can't move any further.
Yeah, because honestly, picture this: if you have, I don't know, let's say it's a microservice ecosystem, and you have 500 services in there, and you have to recommission every one of them in order to change your passwords or your secrets. That's just not gonna.
It's going to get trashy.
So what we really intended when we talked about this and wrote about this is that we should externalize our secrets, and they should be kept inside of a vault, for instance, right? And our services or application, they should fetch these secrets on demand.
So the answer to the question, when do we embed the secrets into the application, is that no, not at build time, no, not at deploy time, no, not at startup time. It's we don't. We let the instances fetch the secret when needed.
So the interesting part about this is that if you design it this way, you also need to apply the fault tolerance, right? I mean, you have to have some sort of retries in there in order, if you have an old secret, right? You have to fetch a new one.
So we change the secret, which means that the instances that are caching the secret will get an error when they're trying to hit the database next time, and they need to.
And the interesting benefit of this, it adds some sort of, how should I say, availability resilience, right? If there is a hiccup on the network, well, they're going to make a retry, maybe fetch a new one, and so on. And there are a certain number of times before it says it's going to fail, right? So this way we can simply rotate our secrets without affecting our ecosystem, so to say, of applications and services. But why? Why did this get through to all the developers that we talked to?
I guess that when we started, we said that we want to take one step away from the bad place we were in, which was that we changed configuration through a rebuild and release. so that it's no longer bake on build, but instead it became the bake on deploy. We bake in the config values when upon every start of an instance. So it's immutable build, a little bit misguided. It was not intended that immutable build would be an immutable build that is baked, finished at some point of time. But another driving factor, I think, is that if we look back a few years, most systems run, or most systems were built on-prem.
Right. And well, then I guess, having a Vault solution wasn't that common, right?
No, I mean, if you wanted a Vault solution, you had to buy a Vault software and install it somewhere. And we all know the procurement processes. Or you had to build a Vault solution yourself, which is not an easy thing to do. So, I mean, Vault are very common in cloud environments, but very uncommon on premises.
Right. So the low maturity level, I guess, in the IT landscapes out there sort of limited the solutions, or the solution space were quite small, right? And people many people thought that they took a step in the right direction by just externalizing the secrets. But the problem is that I think the entire push for immutability made them create immutable deployments.
Yeah.
And if you did that when you changed all your services, and if you had like 500 services or something, then it becomes almost an impossible task to redo it once again, to make them fetch that secret all the time, right? I mean, so people stopped usually at this point. So I think we should have stressed more that there should be an immutable build, but then every secret that belongs to the environment that is dynamic should be fetched in runtime or on demand. So
I think we should put things a little bit in context. I mean, if we look back a few years, I mean, even the forward-leaning shops had still very limited experience of this kind of high quality solutions. The industry as a whole, people were dabbling with it, people were experimenting with it, but really having production grade systems at large scale that did this, there were very few that actually had that, very few that actually had experience with it. If we look at the maturing field, if we look at a few years back, like a few years before the book was written, we started writing the book around 2016, 2017. The 12-factor manifesto was just out of the boxes. And it states store config in the environment.
Right.
Which is an excellent suggestion and in line with it, but it actually doesn't specify the fetch mechanism. Because both injected at startup and fetch out on demand are store config in environment. The fetch mechanism is not clear. So it's not, I mean, if people interpret that as store config in environment, so set it at our environment and variables, and the application will fetch it from the environment. But they will do it on startup. It's a valid interpretation of that piece of advice. And if we look at the 3 Hours of Enterprise Security, which is a seminal paper in this area, that's only 4 years old today. It was published 2016 or 17.
I can't remember. Somewhere around there. Yeah.
17, I think. So it was still kind of hot out of the presses. So I think the world has learned a lot, and that includes us, during this last 3 or 4 years of applying these kinds of techniques. So, yeah, we were a little bit vague about it, but perhaps also because we were not perfectly clear about. I can certainly confess that I was not perfectly clear of what is the actual solution that should look like.
Well, you might have been that, Dan. I wasn't, right?
Of course, Daniel, if I don't listen.
No. All right, so let's summarize all this again.
We
a
have a
question.
Yes, question. Yeah.
Wow.
Cool. Thank you, guys. So, been exploring a little bit with this kind of pattern. It's kind of nice, but it's also like the chicken and egg thing for a service to query a vault for a password. It needs to kind of provide its own identity.
Mm-hmm.
We do a lot of stuff in Azure, and then we have this kind of concept of the managed identity. So
Correct.
the running service has an identity with the in our context, the Azure AD, so we can utilize that kind of thing. But it usually ends up a lot of kind of you kind of lock yourself into the platform, or you have to kind of handle the identity part in a different way. Any reflections on that?
So, well, the part on lock-in, I think my experience has been that you have to choose all the time. You say you're going to be, vendor agnostic or platform agnostic and so on, but at the end you tend to have a thin layer, hopefully, with vendor specific logic. And in this case, it would be how you identify yourself, right? If you in Azure, you use this. AWS, they have a little different mechanism, right? But similar. So I would just say that trying to avoid or making vendor independence, right? I mean, I think that's something that you can strive for, but don't be too afraid to have it well encapsulated in your system. It's not that often you tend to, at least my experience is that you don't tend to change vendor that often, and maybe taking that hit is an acceptable cost at that point, if you choose to.
Oh, I agree. We rarely change or ever change, but
yeah,
to some extent we are idealists as well. So
yeah.
I mean, I remember standing up a decade or two ago talking about the blessings of JDBC. Anyone remember JDBC? How fabulous it is, because you got an API that is totally independent of the underlying vendor. So you don't need to know whether there's an Oracle database or with an SQL database from Microsoft or whatever database, because it's just JDBC. And we all know that after a while you start writing your JDBC and then you start using some, you use JDBC to activate some vendor-specific commands under the hood. And I think that's pretty symptomatic that I realized that in my eager to not bind myself to a platform, I was losing speed. So why am I having an Oracle database if I'm not using the power of the Oracle specific stuff that's in it? But I think still there's a valid idea there, that the idea of JDBC say that, well, try to keep as decoupled as possible, but only couple when you actually get a benefit. And I think this is kind of the same thing, that try to decouple, try to design in a platform agnostic way, but do not be afraid, do not sacrifice the power of the platform you have at hand through stupid, idealistic, no, I will not commit to Azure. I will not commit to AWS because I want to be able to change any cloud vendor at any point of time.
Oh, I totally get it. And one of the kind of pragmatic issues is typically that in that cloud provider's environment, you need to select the few deployment platform that supports this kind of managed identities. Well, right. In the cloud, we have like 100 different ways of doing it, but then you narrow it down to 2 or 3 because those are the ones support
right.
managed identities.
So, yeah.
But also, as you say, it's also when you start diving into it, you get that complexity as well. You get all the complexity of this specific environment. Like you said, I have a few hundred managed identities that I do no longer need to encode, but I'll have to do it through some kind of infrastructure as code management code instead. So,
but I wonder if anyone has measured the cost for you made some vendor specific code and then you wanted to change. How costly was it really to make that change? I mean, did it take like 1 month, 2 months, 3 months? It might be as an acceptable cost comparing to writing that, generic, highly advanced, design to avoid making vendor-specific logic, so to say.
But also to your point, applying sound software design is of course the thing we should do. If we have an infrastructure, we should have an infrastructure package in our code where the infrastructure specific things are hidden under some kind of reasonable abstractions. And we display in the same way as we do like domain-driven design style. Instead of having direct access to a database, we say we got an object that we call a repository. It's just an interface in the domain, but in the infrastructure package, there's an actual implementation of that interface, which contains all the nasty details of connecting to PeopleSoft, or connecting to that specific database, or connecting to that specific sales system, or connecting to whatever it is. Wow. So in that way, at least when we are going to change PeopleSoft to whatever it is, Oracle, Business Suite, something, then at least we don't have to roam the entire code base searching for changes. But at least we'll just have to make a lot of changes in the infrastructure package. And I guess there's some kind of parallel here.
Yeah.
There was an additional question there. So I'm not sure if you want to jump on that or finish.
Please.
Yep. So it's if fetching the secrets instead of a bake-on deploy, does that not just push the can down the road? How do you verify the deployment before issuing secrets? So it's in the chat if you want to read
it. Let's see if I understood the question properly. You're saying that if we don't provide the secrets at deploy time, we're not sure that the deployment is working. Was that the
fetching the secret instead of taking it out does not just push the can down the road? How did that
That's actually tricky.
Yeah.
You don't.
Yeah.
You push and hope.
Dan, I'm going to let you answer that one, I think.
I mean, what you will end up basically is that you don't, but you kind of like rely on heuristic in a way that, well, it did work in the dev environment, it did work in the system integration environment, it did work in the stage environment. Just let's hope for that it works in production.
But there is one thing though that I often apply, and that's environment parity. As I said, what we call the pre-production environment, or the next release environment, or whatever you want to call this environment. It's an environment that's identical to the production.
Daniel, I have to interrupt you because there's some issues with your audio. All of a sudden, something changed. Yeah.
Mute your.
Oh.
Yeah, and the question isn't if.
So let's see what happens.
Does it work? You hear me?
No, hang on.
Yeah, it's better now.
Did you?
Yeah, so the question isn't if the deployment actually works or not. I assume you have a separate pipeline for that. But when, it's echoing.
Yeah.
But yeah, when you deploy a working environment, and now it's fetching secret from some kind of vault, which generates the secrets and stuff. How do the Vault actually know that it's the actual deployment that you just deployed that's fetching the secret?
So, whoa, the audio is really weird now.
Just try to go back as to where it was just by muting Dan.
Now maybe it works.
I think we're good now. Yeah.
Are we good now?
Yeah.
Yeah. Sorry.
They've got for having two Swedes trying to play the audio.
I don't think that was our fault, though. No. Anyhow, okay. So this is the chicken and egg problem. I mean, what we did is that we had a one-time secret that was used at deployment, and our build pipeline provides that into the service or app, and that secret can be used once. And of course, somebody might steal that one-time secret, but now we're talking about a window that's extremely small, and at least that's how we did it. There might be different solutions to this, where I guess I think you can probably set up something like on an infrastructure level that allows only access from certain parts of your infrastructure to your vault. That could also be applied, right? But at least that's how we did it. That we have a one-time secret that allows you to sort of identify yourself and then continue, so to say. It's similar to a token system, I guess. Dan, do you have any other thing that's...
I don't actually. I must confess, I don't have anything sensible to fill onto that.
No. But it is a tricky problem, because how can you make sure that the one that's calling your vault is really the one that they're saying, right? Did that answer your question, or was that too vague?
Yeah, well, sort of. It basically answers the question, but yeah, again, it's a non-answer.
Yeah.
I just to add something. I think there's also a little bit of the idea that one thing that managed environment can do, which you can't do on physical environments, and this is something that was real hard for me to understand, that if you've got physical servers and you mount them to the racks and you start wiring the network, then if you want to start a server and have it, you have to get the secret into that service. For example, if you want to provide some kind of encryption key or something, you have to provide that into it, and the only way to get into it is to like have a secure shell or something that SSH into the machine. But then you have actually been exposing this on the network. So how do you get the secrets into the first secrets into the machines? Then basically the only way is to have the machine manufacturer to embed something on the ship in the box, which is shipped together with it. So it's only there, it never left the box. Something along that line. And this becomes really, really intricate in the physical world. But when you start things in a virtual world, it's not that things are started on the network. It's kind of like, for example, when you provide this, you can actually provide it behind the scene in the kind of back network, behind the curtain, because as these things are only virtual things that are on servers, that are on disk somewhere, then the management system can use disk copy to copy that secret into this virtual machine. There's not even a network here. It's just a disk copy. It's a file copy on a disk somewhere. But from the outside, it looks like this freestanding virtual machine suddenly has got embedded by a secret provided to it through some kind of magic. So this kind of like the managed environment make new things possible that at least I didn't think of and felt very unnatural to me until I started getting used to that. Okay, there's a backpack which I can't see.
Well, you still had kind of the same thing with physical servers as well, where you can use a USB memory stick or something to inject secrets, or just or type stuff on the terminal.
Right.
Yeah.
And you have an auto pen management on servers and so things haven't changed that much, I think. Another thing you can use is that
it's more easily automated now. In my remember that I was 20 years younger than as well. Then I'm a lot more unexperienced. In my mind, it was not as natural as. But of course, you described that. Of course, you can walk around with a USB stick. That's a really good metaphor. Thanks. I steal that metaphor if you allow me to.
Yeah, go ahead. And you also one of the things you can use is MAC addresses, where in a VMware environment or stuff, you have the MAC address, and for physical servers, the MAC address is usually printed on the box. Often in the box it's delivered in as well, so you can scan the MAC addresses and then send the server down to the server room guys.
Yeah.
That is one kind of secret you have. Serial numbers also matches, you might be able to get the serial number of out of a VM, from the outside. So there are techniques, but it's more complicated than just pushing the secrets.
So sorry, guys, I hate to interrupt a good discussion, but the clock is ticking, and I'm not sure how many slides you got left.
Yeah.
No, we're actually wrapping up.
You're
wrapping up. Okay,
so
that's on me then.
That's the last slide. So actually, so if you just look back at this and say that we imagine that we'll have a questions and answers after this one. Just looking back, we covered 4 things. We started with talking about secure by design, just trying to describe the methodology. So secure by design, it's a mindset and it's a strategy for creating secure software. And it piggybacks on our drive as programmers to use good design. Selecting good designs that will also give a security benefit and try to promote those.
And what we sort of illustrated also was that when we stress the importance of avoiding injection attacks and partly also validation of inputs, that sort of ended up with anemic domain objects or domain primitives, and that was very unfortunate because that sort of opened up new security vulnerabilities, and I guess people also forgot that it's not only about input argument validation, it's really about the entire state that's matter when you do validation.
Which is a little bit bizarre, as state validation is something that is very central to, for example, object orientation.
Yeah.
So in some way, we managed to push that out of the light, which of course leads to other problems, including security drawbacks.
Yeah, and perhaps as we just learned here that the chicken and egg problem of the first secret. How should you how do you know which one is which? That sort of maybe pushed people also in the direction of when you externalize your secrets, you create immutable deployments that you provide your secret at deploy time, but that unfortunately makes it more difficult to do secret rotation than you expect. Right, and now this is the last slide.
Yeah, thank you, Richard.
So now, please fire away all your questions that you've been, holding back.
Or comments.
Yeah.
Or ideas.
Yeah. So there was one additional question in regards to the previous topic, which is suggesting to, well, what about TPM? And I think that we got sort of into it. So when we talk about MAC addresses as one possibility of physical property,
right.
I think in my mind, at least, that's what TPM tries to solve by having that embedded trust.
Right.
Well, and on more general notes, I know that the security community in Norway is very vibrant. So we would like to encourage you all to if you have a look at the designs that you have been coming across or evolving yourself and looking at them and saying that, well, I realize that this design I've got has actually got a security benefit as well. Please write an article or a blog post or make a video talking about it, and please ping in all the secure design people in the world saying that I'm applying some ideas from Secure by Design here to showcase this, and ping us and try to get as many people as possible to use this design good designs idea to promote security. Because I guess that's a lot of what communities like OWASP is about, that we don't want this gap between security world and development world. We want to have it bridged or being on the same island. So hope to see a lot of that stuff in the future. We know that 2 colleagues of us are coming to the NDC Oslo to talk about API security, which is, and their presentation will be some around the same kind of philosophy. So we're happy to see that there are a lot of people that are taking interest in that. Even if we now look back at a few years and say that, well, perhaps we got a little bit over-eager in some places, and would like to clarify a little bit of what we said. It's fun to say that security actually got a lot more attention today than 5 years ago.
No doubt.